Good evening, students. So those who have not subscribed my channel, please subscribe my channel and also share my videos. So let us start with another topic of electrical engineering, which is working of a practical transformer on load. So here a transformer is shown and the primary side and the secondary side both are shown over here. The primary side is connected with the voltage source V1, having the primary coil is having N1 number of turns. The secondary side is having N2 number of turns, and since we are dealing here with the transformer on load, so a load is connected to the secondary side. The secondary is not open over here. The load is connected to the secondary side over here. Okay, so the voltage source is connected to the primary side. As soon as the voltage source is connected, the current starts flowing in the primary side. Okay, so let that current be I1. Let that current be I1. The current starts flowing in the primary side and a flux is being set up. Now, the direction of the flux is given by right hand thumb rule. All the four fingers will be denoting the direction of the current, and the thumb, which is stretched outwards, will be denoting the direction of the flux, So here, when I am denoting the direction of the current by my four fingers, the direction of the flux is outwards is denoted upwards. That means the flux which is being set up in the core is given in the direction, this direction. Okay. So this is the direction of the main flux which is being set up in the core. Okay. So we already know that the flux depends upon the MMF. Flux depends upon MMF, and MMF is given by the product of number of turns in the current. Okay, so the flux depends upon MMF. Okay, it depends upon MMF, and MMF is given by the product of number of turns and current. Okay, it depends upon the MMF. MMF is given by number of turns into current. Okay, so as soon as the flux is being set up over here phi, because of the induction, EMF is induced. At the primary side, and that EMF is given by E1. Okay, so this flux now gets linked with the secondary side as well, and when it gets linked over here, because of the mutual induction, the secondary EMF is being set up over here, and that EMF is being given by E2. We have already seen how E2 is being set up by the mutual induction. Okay, so as the EMF is being set up, a current starts flowing through the secondary side because it is connected to the load and the circuit is complete. The secondary is not open over here. Secondary is connected to the load. Load can be any of the load. It can be a resistive load, it can be an inductive load, it can be a capacitive load, or it can be combination of these three. Okay, so it can be RL, RC, RLC, it depends. Okay, so load can be any of the resistive, inductive or capacitive. Okay, so as soon as the EMF is being set up over here, the current starts flowing in the secondary side, and that current is given by I2. Because of this current, the terminal voltage is set up, and that terminal voltage is given by E2. V2 is given by V2. Okay, This terminal voltage is set up because of I2, and because of that I2, a terminal voltage is being set up which is given by V2. Okay. Now here we can see there that in the secondary side, because of the current I2, the MMF, secondary MMF is being created or set up, and that secondary MMF is given by N2 I2. N2 I2. The secondary MMF is being given by N2 I2. Because of this MMF, in the secondary side, it sets up its own flux. It sets up its own flux. That flux is given by phi 2. That flux is given by phi 2. Okay. Because of this MMF, it sets up its own flux. Own flux phi 2. Okay. This phi 2, we can also give the direction of this phi 2. Okay. The current is in this direction. So, the flux, we can see over here, the flux will be upward. Flux setup will be upward because the direction of the current is given by all the four fingers. The four fingers, and the flux direction is given by the thumb outstretched. So the thumb outstretched is given the direction upwards. Okay. So the direction of the flux is upwards. Okay. This is the direction of the flux phi 2. This flux is set up in such a manner that it weakens the main flux. It starts weakening the main flux, and so this core flux starts get weakening. And actually the EMF depends upon the rate of change of flux and the number of turns. Okay, we have already seen in the previous videos, and we already know this fact. So the flux starts weakening. As soon as the flux starts weakening, the induced EMF decreases. It starts decreasing its value, and a limit comes, it starts decreasing, and it decreases and decreases from V1. The value of E1 decreases, and the value of voltage V1 starts increasing. Okay, because of this flux, the secondary MMF N2 I2 are also known as demagnetizing ampere turns, because they are inducing the flux, they are setting up the flux which is responsible for weakening the main flux, which is responsible for weakening the main flux of the core. And as soon as the flux gets reduced, the EMF E1 also starts decreasing, and it decreases in such a manner that the voltage increases. Okay, voltage from the voltage source, the voltage increases, and as the voltage increases, it starts supplying extra current from the primary side. It starts supplying the extra current from the primary side. So let that extra current be I2 dash, because it is responsible. Responsible from the flux in the secondary. So that's why we are giving it I2 dash. Okay, and this is known as the load component of the primary current. Okay, this I2 dash, it is known as load component. This is important, what it is known as load component of primary current. Okay, load component of primary current. So this I2 dash, again it starts flowing through the primary winding. So when it starts flowing, a different MMF is being set up again, and that MMF is given by N1 I2 dash. N1 I2 dash. That MMF is given by N1 I2 dash. Now again we see the direction of the flux, because as soon as the MMF is being set up, the flux is being set up over there. as soon as the MMF is being set up, again a flux is set up because of this load component of primary current. Okay, because of this I2 dash, again a different MMF is being set up, and because of that MMF, flux is being set up. That flux direction is again upwards. Okay, and that flux is given by phi 2 dash. We are naming it by phi 2 dash. So it is set up in such a manner that it nullifies this flux. It nullifies phi 2. It is set up in opposite direction in such a manner that it nullifies phi 2. And the phi 2 was just weakening the main core flux. So it nullifies that flux, and ultimately we are left with the flux phi only, which was being there when there was an ideal case, or which was being there when the transformer was on no load. Okay, so the flux remains same phi in either case. Okay, so phi 2 dash is in such a manner that it nullifies the flux phi 2. It nullifies the flux phi 2. Okay, so phi 2 dash and phi 2 are in opposite direction, so they are nullifying each other, and the main core flux is being left. Now let us find out the value of phi 2 dash will be equal to phi 2. We are finding the value of I2 dash. Now the primary current is constituted of two components. One is the main primary current I1, and second is the I2 dash, which is the load component of the primary current, Like the no load current was having the two components, the working component, the core loss component, and the other component was the magnetizing component. In the similar manner, here the primary current will be having the two components. One is the main component I1, and second is the another component I2 dash, which is helping out in neutralizing the flux generated by the secondary side, which was weakening the main core flux. Okay, so let us find out the value of the I2 dash over here. So phi 2 dash, we can say it is due to the MMF. MMF phi 2 dash is due to the MMF N1 I2 dash. Okay, yes, because of this flux phi 2 dash is set up. Okay, so it is because of N1 I2 dash. Okay, so phi 2 we already know it is due to N2 I2. Okay, so I2 dash will be equal to N2 upon N1 I2. Okay, N2 upon N1 is the transformation ratio. We can denote it by K. Over here. So we can say that I2 dash is equal to K times I2. Okay, so the magnitude of the I2 dash means the extra current which the voltage source was supplying when the secondary flux was being created over here. The magnitude of that current will be equal to K times the secondary current. This concept can be also utilized in the numericals. Okay, so this is also important from the numericals point of view, as well as it is important for the phasor diagrams, which we will be drawing in the next videos. Okay, so whether the in the transformer we are considering the resistance, winding resistance and magnetic leakage or not, the working remains the same. Excuse me. So the working remains the same. Okay, So this is all about for the working of the practical transformer. In the next session, we will be studying about the phasor diagrams. Phasor diagrams are different for the different cases. The transformer having the winding resistance and the magnetic leakage, the phasor diagrams are different for that, and the phasor diagram for the transformer where no winding resistance and magnetic leakage is being considered, the phasor diagrams are different. So we will be drawing all the phasor diagrams in the next sessions. So till then, goodbye. Thank you. Please subscribe my channel. Please share my videos. And if you have any doubt, you can ask me in the comment section. Thank you.